So this ALE service interface is done with three kind of usages. The first one is synchronous mode, second one is polling mode, and third one is asynchronous mode. So I will explain one by one. The first one is synchronous mode. It shows the diagram. I will explain. So first and foremost, the synchronous mode is then method by which multiple RFID readers coordinate their transmissions to avoid interference collisions and then redundant reads. So since RFID works via radio signal, if readers transmit at the same time on the same frequency, they can interfere with each other. So synchronization ensure orderly and efficient tag communication. So what is the need for synchronization, which means it prevents reader to reader interference. It looks like in that diagram. It avoids duplicate tag reads across the overlapping in reader zones. It improves the accuracy and reliability and ensure the fail access. So the types of synchronization modes is based on the time synchronization mode and then frequency synchronization mode. So synchronization in EPC Gen 2, it's using the ultra high frequency. It is a frequency hopping spread spectrum. So readers synchronize by hopping across allows the frequency channels in coordinated manner. For example, you are using warehouse with many readers. So without a synchronization, readers at a dock door at A and dock door B to transmit together, causing interference. Some tags are unreadable. So with synchronization, middleware assigns the time slots. So the next one is polling mode. The polling mode is a reader operation method where the middleware or host system queries readers one by one to collect the tag data. So instead of all readers transmitting simultaneously, that system polls each reader in sequence to request the data. So why polling mode is used, which means it helps to avoid reader to reader interference and to control network traffic and to prioritize the specific readers and to ensure deterministic data collections. So how polling mode is works, which means middleware or host sends the command reader 1, it is in start scanning. So reader 1 collects tag data and sends report back. Then comes to an middleware, then moves to reader 2 for the same process. So this continues in a cycle for all readers. So readers stay idle until they are polled. So what is the advantage in this method? Which means it have no collisions between the readers and easy to manage and coordinate multiple readers and good for time critical operations, for example sequential scannings of gates. So what is the disadvantage of in this, which means it isn't slower about the overall systems because readers wait for their turn, so not efficient for environments with high tag movement. In comes to, and real time tracking is delayed, heavy load on middleware to manage the polling schedule. So use case in the sense warehouse with 4 dock door readers, which means middleware polls reader A. It gathers EPC's pallets. Next polls reader B, then C, then D. So it ensure each dock door is scanned without overlapping the signals. So the next one is asynchronous mode. That asynchronous mode in RFID readers or middleware do not wait for polling or commands or time slots. So instead, readers is independently detect and report tag events whenever they occur. So data is pushed immediately to the host systems or applications as soon as tag is read. The characteristics is event driven, no central control is needed, support for real monitoring, and then the middleware must handle irregular and then high volume data flow. So what is the advantage in that? Means it have real time updates, faster responses and no latency. But what is the advantages while using asynchronous mode? In the sense it doesn't have risk of collisions. So if multiple readers transmit at once, so it can generate huge data volumes also, and it requires strong middleware filtering. For example, access control like gates or doors. As soon as a person with the tag enters, the event is sent instantly to the system. Then comes to another example is a retail checkout, that is a self checkout. So products with the tags trigger events immediately when passed near the reader. The next one is EPC Global Network. So it is a framework developed by EPC Global. It allows the sharing and accessing the information about products and identified by EPC, that is electronic product codes, and it's stored in RFID tags. So it can be connect RFID generated data with supply chain applications, so that manufacturers, distributors, retailers and customers can track and trace products globally. So it works like an IoT for products, enabling real-time visibility across the supply chain. Here, the five core principles of EPC Global Network. The first one is unique identification of objects. So, every item is assigned as a unique electronic product code stored in the RFID tag. So, it ensures that number so it ensures that no two products have the same identity, like digital fingerprint. The second one is data capture through RFID and then sensors, which means RFID readers capture the EPC automatically without human interventions. So it allows fast, bulk and accurate data collection compared to barcodes. The third one is information sharing and access organization. It is that data is shared between trading partners like suppliers and retailers. It enables the collaboration, visibility and coordination across the supply chain. The fourth one is use of standardizations, middleware and then services. So middleware like Savants and services like ALE, both are process the RFID data. So standardization ensure the interoperability between the different vendors and then systems. So final one is global lookup services. It deals the ONS and then EPCS. So in comes to an ONS, it works like DNS for EPC. It directly queries to the right database. In EPCIS, it stores and shares the events data, which means what, when, where and why are the data. So it ensures that any authorized party worldwide can retrieve the product information securely. So I have concluded that the EPC global network, it enables RFID to provide a unique product identification, automated data capture, standardize the data processing, information sharing and then global visibility. So that EPC global network envisions into the two types respiratories also. It having both static and then dynamic data. So both are explored from the forum. So the next one is object naming services. We know so the next one is object naming services, that is ONS. It is a network services. It is in the EPC global network. It works similar to the DNS, that is domain name service system of the internet. So it helps to locate information about the product and identified by an EPC, that is electronic product code. So when an EPC is read from a tag, the ONS tells the system where the related product information is stored. So the functions of ONS, it includes the translate EPC to an information source, it enable the global lookup, and it support the supply chain visibility and interoperability. So how the ONS works, which means an RFID reader scans the tag and retrieves the EPC. So the EPC is sent to the ONS services. ONS looks the EPC number and maps into the URL. Finally, the system fetches the product details. So finally, the ONS is a key component of EPC global network that works like a DNS. It translates the EPC from RFID tag into network address where detailed product information is stored. So when EPC is read, ONS directs query to the right database. It just allows supply chain partners to access the product details globally. So it ensures the interoperability, real-time visibility, and then efficient product tracking across the organization.